Hello and welcome to another live past paper session. Let's do this. This is October November 24 and the variant is 6-2. Okay, I will begin solving. And I have the marking scheme in front. Okay, so the first question says that I'm going to set it up in a way that I can see the screen. Okay, so a random variable x has a distribution 4.5 million and then 1 over 1 million. Use a Poisson distribution. Yes, of course, I will have to use a Poisson distribution because the numbers are really weird. Okay, so I think both have 6, 3 and 2 zeros, 5 zeros, 5 zeros and 5 zeros. That gives me 4.5, so lambda equals to 4.5. Okay, yeah. So greater than or equals to 4. That means 4, 5, 6, 7, and so on. Instead, I do 1 minus probability of 0, 1, 2, and 3. That's 1 e power minus 4.5 minus 4.5 e power minus 4.5 minus e power minus 4.5 into 4.5 squared divided by 2 factorial e power minus 4.5 into 4.5 cube over 3 factorial. Okay, I will put this on my calculator and accumulate. So I think that gives me 1 minus 0.3423 6577. The significant figures is 0.658. Okay, let's go to the next question. It says the lengths of a random sample of 50 rods in a certain region are measured. Using the results, a 95% confidence interval for the mean length in meters of all roads in this region was found to be this. Find the mean length of the 50 roads. The x bar is the midpoint always. It's going to be 245 plus 263 divided by 2. 254. Estimate of the standard deviation of the lens. So I can use one of the boundaries. I'll use the lower boundary, so x bar minus z value. The z value is going to be 97.5 from the table. I don't have the table in front of me. Let me just open that up. Okay, 97.5. So 97.5 is 1.960 minus 1.960. Standard deviation is unknown, so standard deviation divided by root of n root of 50 equals to 245. open up. Have fun of fun. Fun. Okay, let's solve this. $32.5 is the answer. Let's check if that is correct. That is the correct answer. Okay, then it says it is now given that the lengths of the rods in this region are normally distributed. State with a reason whether this fact would make any difference to your calculations in part B. No, because the sample mean is approximately the CLT applies, the CLT already applies, and makes the distribution normal. Normal for large N. Okay, then it says the factory owner models the number of employees who use the factory canteen on any day by the distribution this. In the past, the value of the P was 0.08, so I'm assuming this is going for a hypothesis test. A new menu is introduced in the canteen and the owner wants to test whether the value of P has increased. Okay, on a randomly chosen day, he notes that the number of employees who use the canteen is 23, so the test statistic is 23. Use the binomial distribution to carry out the test at the 10% significance level. So x is greater than or equals to 23. That's going to be 23, 24, and 25. Okay, so writing these down first, 25C 23.2 power 2 and 0.8 power 23 plus 25C 24.2 power 20, 0.2 power 1 and 0.8 power 24, 25C5, C25.2 power 0.8 power 20. Okay, so distribution gives me 0.0982. So 0.0982 is less than the significance level, so reject it's not. There is evidence that percentage has decreased. has increased, sorry, has increased, not decreased, has increased. Given that there are 30 employees at the factory, comment on the suitability of the owner's model. Okay, so the initial model was designed for 25. Okay, a different model multiplied to 30. As the model for 25 does not allow more than 25. Okay, this could have had multiple answers. The marking scheme has multiple answers. You could check it out. Then question number 4 says a normally distributed with means 35 and standard deviation 8.1. Sample size of 140 is chosen, and the sample mean is denoted by x. So x bar follows a normal distribution with 35 comma 8.1 divided by 140.1 square divided by 140. Okay, probability of x bar greater than 36 is probability of z greater than 36 minus 35 divided by root of 8.1 square over 140. What do I get? 1.461. Nine two eight zero. One minus 5 of 1.461. Point 0.072. 0 to 3 significant. Okay, then probability of x bar less than a is equals to 0.96. So z less than a minus 35 over 8.1 over root 140.986. That's phi of a minus 35 over 8.1 over root 140 equals to 0.986. Phi inverse takes me to the other side. It's more like a normal distribution question than anything else. 0.986. 0.986. 9857 and then plus 3, so 2.197. 0.197. Uh, 2.197 I think if you use your calculator, you might end up with 2.198. I'm not absolutely sure, but that's what I think would happen, because there are two numbers that give you this thing from the table. 36.5. Okay. Moving on, question number 5. It says a machine puts sweets into bags at random. The number of lemon and orange sweets in a bag have the independent distributions, this and that, respectively. A bag of sweets is chosen at random. Find the probability the number of lemon sweets in the bag is more than 2 but not more than 2.5. Okay, so lemon has a Poisson distribution with 3.7. More than 2, not more than 5. Probability of 3 plus probability of 4. P power 3.7 into 3.7 cube over 3 factorial plus e power minus 3.7 into 3.7 power 4 over 4 factorial. Not more than 5. So not more than 5 should also include 5. I think I'll have to type this one because it's right in the middle and I don't want to complicate it. Point 5447. 545 should be my final marks. Okay, find the probability that the total number of lemon and orange sweets in the bag is less than 4. So I will have to come up with a distribution for the total. So the total also follows a Poisson distribution with 3.7 and 2.6. That would give me 3.7 plus 2.6 would give me 6.3. Yes, that would give me 6.3. I want the sweets to be less than 4. So probability of 0, 1, 2, and 3. I will write down this in a more convenient way. Okay, and use my calculator to quickly calculate. Point 0.1264, 0.126 basically. I hope that's the correct answer. Yes, that is indeed the correct answer. Then it says 10 bags of sweets chosen at random. Use approximating distributions to find the probability that the total number of lemon seeds in the 10 bags is less than the total number of orange sweets in the 10 bags. Okay. So the mean in of lemon sweets was 3.7, and the variance of lemon sweets was also 2.7. Mean of orange, this is linear combinations, was 2.6, and variance of orange was also 2.6. If I have 10 bags, so the total in 10 bags, total mean 10 into 3.7, plus 10 into 2.6. In fact, I just want something different. I want the total number in the lemon bags to be less than the total number of in the orange bags. Okay, that's fine. So I want a new variable called TL minus TO. Okay, so that's difference TL minus TO. So that is going to have a mean of 10 into 3.7 minus 10 into 2.6. Okay, so 37 minus 26 gives me 11, and the variance is going to be 10 into 3.7 plus 10 into 2.6, and that's going to give me 63. I want the difference to be less than 0, so z less than 0 minus 11 divided by root of 63. Okay. Okay, 5 minus 1.386, 1 minus 5 of 1.386. 1.386 from the table, 1.3869172. So 0.0828. Yep, that is the correct answer. You're seeing what the other solution to by the adding 0.5. Okay, maybe we'll account for the change in distribution, but that's not necessary. This answer is also correct. It says the time x hours taken by a large number of people to complete a challenge is modeled by the random probability density function this, where a and b constants. State what the constants a and b represent in this context. So minimum and maximum time. Okay, show that a equals to this. So I'm going to integrate from a to b and say that that is equals to 1. So x power minus 2 plus 1 over minus 1. A to b equals to 1 minus 1 over x from a to b. Okay, 1 over a equals to 1 plus 1 over b. So 1 over a equals to b plus 1, and then I take a reciprocal on both sides. Okay, it is now given that expected value of x is ln3. Show that b equals to 2. Find the value of a. 4-mark question. And it says find the median as well. So you integrate from a to b. Again, this time x into 1 over x square. And that should equal ln3, expected value of x. So a to b, 1 over x, ln3. The ln x with limits is equals to ln3. The ln b minus ln a equals to ln3. ln b over a equals to ln3. And b over a should equal 3. B equals to 3a. Okay, So the previous equation was b over b plus 1. Okay, maybe I could best prove b. I have a equals to b over b plus 1. So b equals to 3, b plus 1. This b cancels out with that b. B plus 1 equals to 3, b equals to 2. B equals to 2, 2 over 3. Okay, I think that's relatively simple. Then it says find the median of x. So you start with a came out as 2/3. So you integrate from 2/3 to m. What do you integrate? You integrate 1 over x squared only and say that the probability has to be minus 0.5. Maybe it would have been easier with m and the other limit because it's a whole number. Okay, so minus 1 over m minus 1 over 2 over 3 to 0.5 minus 1 over m plus 3 over 2 equals to 0.5. 3 over 2 minus 0.5 equals to 1 over m. 1 equals to 1 over m, and m is therefore equals to 1. Yep, that is the correct answer. Let's move on to the last question. I think that's the last question. Yeah, that is the last question. Rather short paper. Heights of 1-year-old trees of a certain variety are known to have mean 2.3, and a scientist believes that on average trees of this age and variety in a region are slightly taller than in other places. She plans to carry out the hypothesis at the 2% significance level in order to test her belief. State the probability that she will make a type 1 error. Type 1 error is basically significance level, so type 1 error probability should be 2%. She takes a random sample of 100 in the region and tests their height. Her results are summarized below. Okay, so first I'll have to find the unbiased estimates of mean and variance. I have x bar from here, 238 divided by 100, that's 2.38. Okay, and for the variance, I'm going to use this data and unbias it. I'm going to say 100 over 99 and 580 over 100 minus 0.38 squared. Point 0.1356 divided by 0.137. Yeah, I'm correct values now. Okay, so the test is that the original is 2.3. The researcher believes what? The scientist believes that slightly taller, so greater than 2.3. You draw the critical region at 2%, so 98%. Anything 98 comes up here. 98 has to be searched from inside, so 98%, right? That's 9798 plus 2, so 2.054. 0.054 is my critical value. Then I find the z value of my test statistic. It's 2.38 minus 2.3 divided by 0.137 divided by 100 in a root. Two 2.161. Okay, that's inside the critical region, so I'm going to reject H naught. There is evidence that the trees are taller. Okay, the scientist carries out the test correctly, but another scientist claims that he has made a type 2 error. No, because H naught was rejected. Type 2 error is only possible when H naught is accepted. Okay, that brings us to the end of the exam. I will see you with another paper in the next video. Thank you.